Now that we've finished deriving the equations of constant acceleration, we'll go ahead and do some mock examples. Right here we have a question. A body moves along a straight line from A to B with a uniform acceleration of 2/3 meters per second. So we are going to start straight away with summarizing this question. A body moves along a straight line from A to B. So if this is our straight line, it's moving from point A to point B. And in this straight line from point A to B, it's moving with a uniform acceleration. So the acceleration of this body is 2/3 meters per second. Of course, acceleration is meters per second squared. So meters per second squared. The time this thing is taking is 12 seconds. So the time taken here is 12 seconds. The velocity at B is 25 meters per second. So the final velocity, because it starts from A to go to B. So the velocity at A is what we shall be calling our initial velocity. It's not given in the question. The final velocity at B, which we shall call capital V, is 25 meters per second. Find the velocity at A. So we are being required to find the initial velocity at A. So to find the velocity at A, we shall use the first equation of motion. V is equal to U plus AT. We have our final velocity as 25 meters per second. So 25 is going to be equal to the initial velocity U, which we are looking for, which is U plus the acceleration, which is 2/3, times the time taken from A to B, which is 12 seconds. And definitely when we make U the subject of the formula right there, we shall end up with our answer as 17 meters per second. That's our initial velocity, and that's part A answered. Now part B of the question requires us to find the distance AB. When it's moving from A to B, what is the distance? So to find the distance moved from point A to point B, we are going to use V squared is equal to, this is part B, V squared is equal to U squared plus 2AS. We'll use that equation of that formula. So our final velocity V here is 25. So this is going to become 25 squared is going to be the initial 17 squared plus 2 times acceleration. Now we have our acceleration as 2/3 meters per second. So times 2/3 times the distance. Now it is the distance we are looking for, the distance of AB. So the distance, we shall leave it as S. So of course this, when we make S the subject of the formula, this is going to end up in 25 squared minus 17 squared. We have shifted that 17 to come this way. Is going to be equal to, here we remain with 2 times 2 is 4/3 times S. Now definitely this is going to result into, when we make S the subject of the formula, this is going to become 25 squared minus 17 squared. Divide all that by 4 times 3. And definitely now our value of S, the distance between A and B, is going to end up being 252 meters. Now this is when we've used this. Now remember, we have up to 5 equations of motion, so it means that you can as well use any other, as long as you see it will work for you. So part B can also be done in an alternative way. We've used this equation, we can also use this equation to get the distance. S is equal to UT plus 1/2 AT squared. Now the initial velocity U is 17. We got it here, so it's going to be 17 times the time. The time taken to move from here to here is 12 times 12 plus 1/2 times the acceleration. The acceleration is 2/3 times time squared. 9 time is still 12 squared. And when we add all this up, you still end up with 252 meters. 252, just the same as this. So with part B, you can use this or you can use that formula. Either way, you will still be able to get the same answer.
This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakurame, helping you manifest excellence.